All right, in this video, I'm going to be talking about pages 12 through 15 in the notes packet. This is where we're really diving into functions, right, and getting really used to using our calculator to solve for both input values and output values. So if we have a function, right, y equals f of x, remember y and f of x, those can be written interchangeably. So if we have an input and we're solving for an output, that's the simplest case, right? For example, if f of x is 3x squared, what's the value of f of 5? We're saying 5 is the input value. Let's put 5 into the function. F of 5 would then be 3 times 5 squared. That would be 75. Sometimes, though, we'll be given an output value and we need to work backwards to solve an input. So we're saying for what value of x is f of x 48? Well, if f of x is 3x squared, then that means 48 would be 3x squared. You can divide both sides by 3. You get 16 is equal to x squared, which means x would be equal to positive or negative 4, right? The square root of 16. For simple functions, it's pretty straightforward to do that by hand, but for more complex functions, we're just going to rely on our graphing calculator. So we're going to be looking at the function y equals negative x squared plus 5x. And we're going to start by just putting that into our calculator. So I'm going to go here, go y equals. We're looking at negative 2x squared plus 5x minus 5, right? So you're going to go y equals and then put it in your calculator there. All right? And now if we want to find the value of y when x is 6, so here we're inputting 6 and we're outputting some value, we're going to go second and then this button up here. We're going to click value. We want to do that when x is 6. And that'll tell us, well, when x is 6, y is negative 47. Okay? But what if we want to go the other way, right? What if we're given an output and we want to solve the input? Well, then we want to put the function and the output value in our y equals. So I see I have the function still there. If we're looking for what input leads to an output of negative 3, when we want to put negative 3 there. And then on the calculator, we're going to go second trace again, but now we're going to go down to intersect. And we're going to make sure that our y1 is our function, y2 is our value, and we can see here that it's going to intersect in 2 places. So there's going to be 2 solutions here. So the first one is going to be 0.5. The second one, we need to do it again. Go down to intersect, and now we want to arrow over to the other intersection. We're going to hit enter 3 times, and we can see that it is 2. So essentially, you're graphing a line at the output value, and you're finding the 2 input values for which your function hits that line. All right, so now let's do some practice with that. So this is finally on page 15. So the first function we're going to be working with is 5 to the t minus 10. So I'm going to go to my y equals. I'm going to put 5 to the x power. And then I can delete the rest of this. Probably should just deleted the whole function to begin with, but yeah, let's just do that. 5 to the t, 5 to the x. So just always input x no matter what the variable is. Minus 10. And then here we want to find s of 1, so we want to find the output when it is 1. And for these, feel free to do it without a calculator. Actually, if that is easier, for many of them it probably will be. So but we can do it on here. Calc value. What am I inputting? I'm inputting 1, and the answer is -5. All right, now I'm looking, what is the input value for which my output value is 2? So now I need to go back here. I need to change my output value from -3 to 2. And then I want to find the intersection. So there. And I can see that that is 1.544. So t would be 1.544. Okay. And so you just want to do the same thing for all of these functions down here. So I'm not going to talk much while doing this. I'm just going to be inputting it in. But feel free to go, if you're having trouble with any of them, see what I input into my calculator and try and see if yours looks different. So starting with the first one. All right, and you see that this one is interesting because it is a trigonometric function, 2 times cosine x minus 1. So when we go to find the intersection, there are many solutions to this, right? There are infinitely many. So we can see by the fact that this line hits a bunch of times. So I just want you to find the one. You can find any of them. I'm going to do the one closest to 0 on the right. So if I want to find this intersection here, can do that, and it's going to tell me that the intersection is 0.841. There are lots of solutions to that one. All right, so if you have any questions about these, please let me know.